Have you ever looked up at the night sky and wondered where it all came from? Not just the stars we see, but the planets, the moons, the entire cosmic dance? The answer lies in some of the most beautiful and chaotic places in the universe, stellar nurseries. Today, we're going to journey deep into these cosmic cradles to witness the birth of new solar systems. Imagine a cloud, but not like any on Earth. This cloud is unimaginably vast, stretching 4 light-years across space. It's cold, dark, and made mostly of hydrogen gas and tiny specks of dust, the raw ingredients for everything that will ever be in a solar system. These are the giant molecular clouds, the quiet giants of the galaxy. For millions of years, these clouds drift peacefully through the cosmos, but they're not static. Inside, gravity is always at work, a patient sculptor pulling matter together. The cloud is a delicate balance between gravity trying to collapse it and the internal pressure of the gas pushing it outward. All it takes is a little push to tip the scales. This push can come from a few places. Maybe it's the shockwave from a nearby supernova, the explosive death of a massive star. Or perhaps it's the gravitational ripple from 2 galaxies colliding. Even the powerful stellar winds from young, hot stars can compress the gas. Whatever the trigger, a region within the cloud starts to collapse. Gravity wins. As this region, called a dense core, collapses, something amazing happens. It starts to fragment into smaller, denser clumps. Think of it like a giant ball of dough being broken into dozens of smaller pieces. Each one of these clumps has the potential to become a new star. This is why stars are rarely born alone. They're usually born in clusters like cosmic siblings. Let's focus on one of these clumps. As it shrinks, the material at the center gets squeezed tighter and tighter. This compression heats it up, just like pumping a bicycle tire makes the pump hot. The core begins to glow, first in infrared light, invisible to our eyes, but shining brightly for telescopes that can see in that spectrum. This glowing embryonic star is called a protostar. It's not a true star yet because it's not hot enough for nuclear fusion, but it's getting there. The protostar is a hungry baby, surrounded by a swirling disk of gas and dust that continues to fall onto it. This is the law of conservation of angular momentum at work. Just like a figure skater spins faster when they pull their arms in, the collapsing cloud spins faster as it shrinks, flattening out into a disk. We call this a protoplanetary disk, and it is the birthplace of planets. This disk is a bustling construction zone. Material from the outer edges spirals inward, feeding the growing protostar at the center. For tens of thousands of years, the protostar gorges itself, growing in mass and temperature. The pressure in its core builds relentlessly. Eventually, a critical threshold is reached. The core becomes so hot and dense, we're talking millions of degrees, that something incredible ignites: nuclear fusion. Hydrogen atoms begin to fuse together to form helium, releasing a tremendous amount of energy. A star is born. This moment is dramatic. The newborn star unleashes powerful jets of energy and particles from its poles, like cosmic birth announcements. These jets, combined with intense radiation, create a powerful stellar wind that blasts away the remaining gas and dust from its immediate vicinity, carving out a cavity in the surrounding nebula. The star has finally emerged from its cocoon, shining brightly for the first time. But what about the disk? The protoplanetary disk, now orbiting the young star, is where the next chapter of creation unfolds. This is where planets are made. The process starts small. Tiny dust grains, some no bigger than particles of smoke, begin to stick together. It's a bit like dust bunnies forming under your bed, but on a cosmic scale. Through static electricity and other forces, these tiny grains clump into pebbles. Pebbles collide and merge to form larger rocks, and the rocks smash together to build boulder-sized objects called planetesimals. We're now talking about objects kilometers across. This process is called accretion. It's a violent, chaotic demolition derby where the biggest objects sweep up the smaller ones, growing larger and larger.
Ow.
Over millions of years, these planetesimals continue to collide and merge. The largest ones, with the strongest gravity, become the winners. They pull in more and more material, their gravitational influence growing until they clear out their own orbits around the star. These become the protoplanets, the seeds of the planets we know today. The type of planet that forms depends on where it is in the disk. Close to the hot young star, it's too warm for ices like water, methane, and ammonia to exist. Only rocky materials and metals can condense here. This is why the inner solar systems, like our own, have smaller rocky planets like Mercury, Venus, Earth, and Mars. Further out, beyond what's called the frost line, it's cold enough for those ices to freeze. This adds a huge amount of solid material to the planetary construction kit. Protoplanets in this region can grow much, much larger, becoming massive cores of rock and ice. Their gravity becomes so immense that they start pulling in the vast amounts of hydrogen and helium gas that still exist in the outer disk. This is how the gas giants, like Jupiter and Saturn, are born. Even further out, where the gas is less dense, you get the ice giants, like Uranus and Neptune. This whole process, from a collapsing cloud to a full-fledged solar system, isn't neat and tidy. It's a period of intense gravitational jostling. Planets can migrate from where they were born, their orbits shifting and changing due to interactions with each other and the remaining disk. Some planets might even get flung out of the system entirely, destined to become rogue planets wandering alone through the galaxy. Eventually, after about 10 to 100 million years, the young star's radiation and winds blow away the last of the gas and dust from the disk. The construction phase is over. What's left is a new young solar system, a star, a family of planets, and a collection of leftover asteroids and comets. When we look at stunning images from telescopes like Hubble and the James Webb Space Telescope, we're not just seeing pretty pictures. We are looking at these stellar nurseries in action. You can see the glowing protostars, the dark silhouettes of protoplanetary disks, and the cavities carved out by newborn stars. We are, in a very real sense, watching other solar systems being born right now. Every star in the night sky, including our own sun, went through this incredible journey. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was forged in the heart of a star and scattered through a stellar nursery, ready to be gathered up into a new star and a new planet called Earth. We are literally made of stardust. So the next time you gaze at the stars, remember the violent, beautiful, and creative process that brought them into being. You're looking at the grand, ongoing story of cosmic creation written in clouds of gas and dust across the galaxy. Thanks for joining me on this journey into the cosmic cradles of the universe. If you enjoyed this exploration, don't forget to like, subscribe, and hit that notification bell for more deep dives into the cosmos. See you next time.